Hello again, everyone. Happy Tuesday. Hope you all have been having a great week so far. Had a great week last week with Elimination. Today we're going to do some review for a pretty exciting thing happening tomorrow and Thursday. We'll get to that later. All right, so for today, guys, we got two activities for you guys. So first of all, I want you guys to just follow along with this video lesson. Everything today is review. So what I would love you guys to do is to pause this video on each slide and try the questions on your own first. Okay, so do them on a piece of paper, try it out, and then I'll kind of go over it. That way you're getting the practice, and I'm kind of just reinforcing if you get that question right or wrong. Because instead of you just watching me, that's not very effective. We want you guys to try the problems out for your own. Okay, and the second thing I want you guys to do is there is a review worksheet posted on the P-Learning page there. Okay, now I understand not many of you probably have printers, and that's okay. But if you do, I posted it as both a PDF and a Word doc. Okay, it's the same thing both times. But if you have a printer, feel free, print it out and do the work right on there. If you don't, you guys can absolutely do the work in a notebook to help you out. Okay, and then the answer key will be posted as well. So if you do get stuck, you can reference back to that if you need to. Okay. So for today, we're going to go through just like one question from each type that we've been talking about. So we're going to do one classify. We're going to solve one by substitution, solve one by elimination, and one where you can try the method on your own. Okay, what's classifying? So the big thing here, guys, is I'm telling you to classify without solving. When I say without solving, that doesn't mean to just not do the question. It doesn't mean just don't do anything. What it means is we're not trying to get the actual solution. We don't want the ordered pair where those two lines intersect. Instead, we want to compare both equations and determine what type of system it is. Is it an independent system, which means it has one solution? Is it a dependent system, which means it has an infinite number of solutions? Or is it an inconsistent system, which means it has no solution? And we do that by converting both equations to slope-intercept form and then comparing the slopes and the y-intercepts. Okay, so we're going to do these two problems or these two equations separately, okay, because they need both in the be in slope-intercept form. So first, let's convert this equation to slope-intercept form. So it's currently x minus 2y equals 8. So again, slope-intercept form means y is by itself. So I'm going to go ahead and do that. So first, we're going to subtract x from both sides. Okay, so I'm left with negative 2y equals negative x plus 8. And then we're going to divide both sides by negative 2. Okay. So this equation ends up being, my 2's cancel out here. So you got y is going to equal, I have negative x divided by negative 2. Again, there's a visible 1 in front of that x here, right? A visible 1 here. So negative x over negative 2 will become positive 1/2 x. And then 8 divided by negative 2 is negative 4. Okay, so there's that equation converted to slope-intercept form. Slope is 1/2, y-intercept is negative 4. Okay, now for our second equation, it's currently in slope-intercept, or I'm sorry, it's in point-slope form, but we want to convert that into slope-intercept form as well. So we're going to start by distributing that 1/2 into those parentheses. So you get y minus 4 equals 1/2 x, and 1/2 times negative 16 will be negative 8. Okay, now let's get y by itself. So I'm going to add 4 to both sides. So we get y is going to equal 1/2 x, and negative 8 plus 4 is negative 4. You notice here is both equations are the exact same. Same slope, same y-intercept. So since they're both the same, that means they're the same line, so they're coinciding, which means the system has an infinite number of solutions, so it's a dependent system. Okay? If the slopes were the same and the y-intercepts were different, they wouldn't intersect, so it'd have no solution, so it'd be an inconsistent system. And then if the slopes were different in any way, they have to intersect at one point, so it'd be an independent system. Okay, there's our first example. Next one, I want you to solve this system by substitution. Okay, I forgot to say this in the last slide, but go ahead, pause this video. Okay, try this one out first, and when you got an answer, go ahead and unpause and we'll go over it. Okay, so let's go over this one, guys. So hopefully you should get a solution of 3, 0. 3, 0 is your solution. And again, we specified substitution, so I want you to solve it that way. So when it comes to substitution, guys, we need one of the equations to be solved for one of the variables. Again, doesn't matter which equation, and doesn't matter which variable. when I'm looking at this, I'm looking at my options, okay? I see, all right, this x term here has a coefficient of 2. This y term in my first equation has a coefficient of -1. In my bottom equation, this x term here has a coefficient of +1, and the y term has a coefficient of -1. What I find to be the easiest is that we want to get the variable by itself that has a coefficient of 1. That requires the least amount of steps. And I see that happening in the second equation here. So I want to get x by itself in my bottom equation, because the only thing we have to do for that is to add y to both sides. So let's go ahead and do that. We're going to add y to both sides in my bottom equation to get x by itself. So I get x equals y plus 3. Okay. And again, here's the beautiful thing about substitution. Once a variable is by itself, we're going to take what that variable equals, is y plus 3, and we're going to substitute that into my other equation for y. Come on, there it is. Okay. So, oh, sorry, for x. So we're going to plug that into my top equation for x. So now our top equation is going to become 2 times x, but we just said or figured out that x is equal to y plus 3. Okay. Now write the rest of the equation. So minus y equals 6. Let's go ahead and solve that out now. So we're going to distribute this 2. So you get 2y plus 6 minus y equals 6. Let's combine terms. So 2y minus y gives me y plus 6 equals 6. Okay, we're going to subtract 6 from both sides. Don't freak out, because 6 minus 6 is just equal to 0. Okay? And then once we have the value of one variable, let's go ahead and plug it into either original equation. I'm going to plug it into this one right here. Let's plug into this guy. Okay, so now we'd say that x is going to equal y plus 3, but we just said y was 0, so it's really 0 plus 3, so x is going to equal 3. Okay, and again, always write our answers in ordered pair, so it's the point 3, 0. There we go. That's what we solve by substitution. We're going to get a variable by itself and then plug that expression into the other equation. Next, I want you guys to solve this by elimination. Just go ahead and pause, try on your own, and then unpause when you're ready. All right, let's go ahead and do it. So our first step for elimination, we need all our terms to be lined up. So I need x's, y's, and then our constants, okay? So this is where Ms. Sofianos told you guys last week we want this in, we call it kind of semi-standard form. It's not the formal standard form, it's not, but we do want x and y on the same side of the equation. So for this top equation here, we want to get the x term on the same side as y. So we're going to subtract 2x from both sides first. Okay, and when we do that, we get negative 2x plus y equals 1. Now my bottom equation was already in that semi-standard form, so I can leave that as negative 4x plus 6y equals negative 18. Okay. So now, for elimination to work, we want to add the equations together. And when we add them together, we want one of the variables to cancel out. And what I like to do, guys, is think ahead. All right, if I were to add these equations together right now, would either variable be eliminated? Well, let's check. If I add negative 2x plus negative 4x, that's negative 6x. Nope, I need that to be a 0, so that doesn't work. Y plus 6y is 7y. That one doesn't eliminate either. So what we're going to do is multiply one equation through by a term, by a number. Okay, so to do that, I'm looking at these x term here. And I said, well, if this x term had a coefficient of positive 4, I know positive 4 minus 4 would give me 0. So that's what we want to do. We want to go ahead and get this equation here. Let's multiply everything through by a negative 2. Because negative 2 times negative 2 will give me positive 4. Okay, and when we do that, okay, we get 4x minus 2y, because we're going to distribute that negative 2 to both terms, and it's going to equal negative 2. Okay, now we can go ahead and add those equations together. So negative 4x plus 4x is 0, so that cancels out. 6y minus 2y is 4y. Negative 18 minus 2 is negative 20. Do you all see that? We're adding those equations together. Okay, and that x term got eliminated. Now let's get y by itself. Divide both sides by 4, divide by 4, and y is going to be -5. Once we get the value for one of the variables, let's go ahead now. I'm going to plug that back into either original equation. So I don't know. Let's plug it into this one right here. Okay, so we're going to say -2x plus y, so then -5 is going to equal 1. So I'm going to subtract or add 5 to both sides. So -2x equals 6. Divide both sides by -2, and x is going to be -3. Okay. So our solution here, guys, is going to be the point -3, -5. All right. One more example for you guys. Solve the following system using either method. Okay, go ahead and pause this. Give it a try, and unpause when you're ready. All right, welcome back. So this one's pretty interesting. This one ends up being no solution. But let's look at that first. So I'm looking at this, guys, and honestly, this one can go either way. Substitution wouldn't be bad because y already has a coefficient of 1. So you could just subtract 3x from both sides to get y by itself. I chose to use elimination. But again, if you use substitution, you're fine. But for elimination here, what I notice is, all right, we have a 6x and a 3x. So I want to cancel out this x term. The way I cancel out this x term would be if this bottom x term had a coefficient of -6. So what we're going to do is I'm going to multiply the whole bottom equation by a -2. Okay, so top equation didn't change. I'm leaving that as 6x plus 2y equals 18. Then the bottom equation, when I multiply through by -2, we get -6x minus 2y equals 26. Okay, now let's go ahead and add those equations together because my x's will cancel out. But what's interesting here is that also 2y minus 2y is also 0. So I'm left with a 0 on the left-hand side. Both variables cancel out. And that's going to equal 18 plus 26 is 44. So let's think about that. Both variables cancel out. I'm left with a statement 0 equals 24, which is not true. Since we got left with an untrue statement, we have to write no solution. If that statement was true, let's say I got 0 equals 0, then we would write it has an infinite number of solutions. Okay? So that's the part for today. Okay, I do want to talk about tomorrow for a second, so please don't end this video just yet. I have some important info for you guys. Okay, remember to go ahead and work on that worksheet now. So tomorrow, okay, we're going to try something new. I'm really, really excited about it. We are going to do Zoom meetings with you all. Okay, the reason I'm excited is I finally get to talk to you guys. You get to ask us questions. We get to go over this stuff together. So just to try to keep it organized, we gave you guys these meeting times. Okay, so B period is at 10 a.m., C period 11, so on and so forth. You guys can see that here. Okay, so what's going to happen is we're going to have posted on P-Learning 5 different Zoom meeting links. Okay, so if you're in B period, you're going to log on to P-Learning, enter that meeting at 10 a.m. It would also be emailed to you guys, so you don't have to worry about that. Now, what I want to tell you guys, okay, is that if you cannot make this time, let's say you know you're in C period and you definitely can't meet at 11 a.m. for a Zoom meeting, that is okay. Please email us though. Reach out to your teacher, send us a remind message, and we'll find you maybe a different time that does work for you. Or if you're not free at all from 10 to 2, that's also okay. We've thought about how we can be available outside this time to work with students who need extra help. Okay, but the big thing is please don't just sit there, not know what to do. Please reach out to us. We're going to try this out. You know, we want to be able to interact with you guys. It's tough to just talk back and forth on discussion boards. So this will really give us a chance to really be able to talk to you guys and answer your questions and everything we've talked about so far in distance learning. Okay, so again, if any questions, please reach out to us. Okay, I'll talk to you guys later.